This is activity 4, filling a bucket, from lesson 11, interpreting graphs of proportional relationships. And in this activity, you're given a graph of the amount of water that flows into a bucket in gallons, given a certain amount of time in seconds. And it tells you that you have the point 12.5, which is right here, and asks you what that point is. What does it tell you about the water that's flowing into the bucket, and then how many gallons of water were in the bucket after 1 second, which is right here. So first of all, they have to tell you in the problem that that the water is flowing into the bucket at a steady rate, a constant rate. It's linear, it's not changing, it's flowing into the bucket at a steady rate. That means that it's a proportional relationship, and you can see that from the graph. It's a straight line, and it goes through 0, 0 down here. And so once you know that, you can go out to this point, 12.5, and realize that it's 12 seconds. So it takes 12 seconds for water to flow in the bucket and to fill to 5 gallons. Now that's probably the size of the bucket. A 5-gallon bucket is a normal size for a bucket. They actually don't tell you how much water the bucket holds, but let's say it holds 5 gallons, so it fills up in 12 seconds. So water is flowing into that bucket, takes 12 seconds, so imagine standing there for 12 seconds, and 5 gallons of water flows in the bucket and fills it. So you read along the x-axis to 12 seconds. You read up to this point, which is 5 gallons. So you read over here to the y-axis, and that tells you it's 5 gallons. So what does that point mean? It means that there's 5 gallons of water that flows into the bucket per 12 seconds. So that's y per x, or y divided by x. So that's 5 gallons per 12 seconds. So that's 5/12 of a gallon per second. So if you do this division, this is the constant of proportionality. If you do this division, it works out to be 5/12 gallons per 1 second. So whenever you have a fraction like this, and you divide it, 5 divided by 12, that becomes 5/12 per 1. In this case, per 1 second. So it's 5 gallons per 12 seconds, which is equal to 5/12 of a gallon per second. So then they ask you what happens after 1 second. Well, this is that 1 second right here, and you go to right here. So what's this point right here? Well, it's 5/12 of a gallon. So this is 1 gallon. 5/12 of a gallon is a little bit less than half of a gallon. So when I zoomed in and I looked at this, I noticed that this line actually does not quite go through 0, 0. And that throws these points off. This point is placed closer to half of a gallon, so 6/12 of a gallon, whereas it should be 5/12 of a gallon. And if you go out to here, and we'll do this in just a second, this is what happens after 1 gallon. So how many seconds does it take to have 1 gallon in the bucket? So I redrew this line with it going through 0, 0. It seems like a minor point, but it actually makes the drawing fit better to the story, actually more accurately to what the story is. So I drew it through 0, 0, and this is a better fit. This is 5/12 of a gallon, a little bit less than half. And if you go up to this point, this is in 2 seconds, there's going to be twice as much water, or 10/12 of a gallon. So right here, that's about 10/12. And if you go past that, it takes, to have 1 gallon flow into the bucket, it takes 2 seconds and 4/10 of a second. So I'll show you that calculation in just a moment, which is a little bit less than half. It's 1/10 less than half. So this is 4/10. All right, so if you look at the equation for a proportional relationship, it's y equals kx, and we now know that the constant of proportionality is 5/12. So this line tells us that for any amount of x that we have, the amount of water in the bucket is going to be 5/12 the amount of time that it takes. So in 1 second, the amount of water in the bucket is 5/12 of that 1 second. So that means that the amount of water in the bucket is 5/12 of a gallon. So this is in 1 second, you have 5/12 of a gallon. Now, if you want to figure out what x is, if you're given the number of gallons and you want to calculate, gee, how long did it take for that number of gallons to flow into the bucket? That is the reciprocal relationship. So now you're going the other way on those tables that we put together. You had the x values and the y values, and you usually go from the left to the right. You usually go from given an x value to calculating a y value. But in this case, you're going to be given a y value, so 1 gallon. So what's the x value? Well, that's the multiplicative inverse of the constant of proportionality, the reciprocal of the constant of proportionality, which is 12/5. So now it's 12/5 seconds times 1 gallon. So it's 12/5 seconds times 1 gallon equals the amount of time it takes to have that 1 gallon in the bucket. So 12/5 seconds is 2 seconds. 2 times 5 is 10. That'd be 2 seconds plus 2/5 left over. So that's 4/10. So it's 2 seconds and 4/10 of a second. So that goes up to this point right here, which tells you that for 1 gallon of water, it takes 2 4/10 of a second. So this is the reciprocal relationship, and this is the relationship given the time, how many gallons flow into the bucket, and this is the relationship given the number of gallons in the bucket, how long does that take, which will be x. And I put this point out here just as a check. If you go out for 6 seconds, that's half of 12 seconds. And if you remember, it was 12 seconds and 5 gallons. So 6 seconds is going to be half the number of gallons, or 2.5 gallons. And this point right here is a better placement of 2.5 right there.